Hello everyone. We are going to be revising all the learnings that we have done so far with linked list topic. So we are going to be looking back at what are the different topics that we started, starting from day 15 where we had introduction on linked list, where we described how a singly linked list looks like, uh, how a singly linked list look like, right? With respect to how a data is stored in a singly linked list and a next pointer pointing to the next node. We have even discussed what an head node and an ending node. Usually in singly linked list, we have said the ending node is going to be null, pointing to a null pointer, right? So, and also we have said the different operations that we can perform using singly linked list, like insertion, deletion, updation, reading of a singly linked list, iterating from the head node to the end node, and different operations, custom operations like swapping of two nodes or having to sort a linked list, right? So we can even have delete operation at a specific value or a specific node, many such things. And we have also discussed very brief about a difference between array and a linked list, right? What are the different advantages and disadvantages of using either an array or a singly linked list, right? uh, we have talked about arrays, which are predefined, and also dynamic array where the memory allocation can grow as the size increases, right? Even though we call it dynamic array, the one interesting topic there is we either double the size from the initial definition, or we half the size if the size is required to be reduced, right? And in day 16, then we started off with singly linked list. We had uh, a code snippet that we looked into in JSPin, and we looked at all the different operations, right? And then we went on to doubly linked list, and we also understood how the pointers of previous and next pointers uh, are used. Here only a next pointer and data is used, while here next and previous pointers are used. So we have even discussed the two differences between singly and doubly linked list, where there are two pointers in doubly linked list and one pointer in singly linked list. How we can iterate both forward and backward in doubly linked list, while in singly linked list it's only a forward traversal, right? So those are few key points. Circular linked list was the last topic that we had, right? Circular linked list, where the ending node or the last node will point back to the first node, right? So that's what we have seen, and we have also seen the code for it in JSPin. And finally, we had certain problems in day 19 where reverse a singly linked list and a doubly linked list using iterative and recursive way, right? Those are few things that we have seen. uh, so here, if I had only showed singly linked list, and doubly linked list code I had shown but not explained in detail. But just to quickly understand what we had, or the idea behind how we reverse a singly linked list, iteratively we uh, iterate using a while loop with a current node, and then we keep track of the current node and current node not next in a temporary value, and we swap the value of current dot next to the previous pointer, which would initially be at null, and we also say previous pointer takes up the current node, so that the establishment of reversal of a pointer is done. And then we have the uh, temporary value of current dot next, which is helpful for iterating with the while loop. So that way we reverse it, and we have walked through the code in JSMin. And in reversal of linked list. Stack space in time space complexity. The iterative way takes O of n, while space complexity is O of 1. While in recursive time complexity, it is O of n, and space complexity is also O of n. While uh, the stacks are created in recursive linked list. Uh, the recursion stack is created, and the key idea here is, so we recurse with a base case saying that node is either null or node.next is null, and we return the specific node and we assign it to the head, right? So let's say we have 1 2 3 4 as a 1 2 3 4 and 4 pointing to null. So recursion stack loads it up this way: 1 2 3 4, right? While we have this kind of recursion stack which uh, uh, iterates first with 1, and then we get 2, and then we had 3, and then we have 4, right? So now what we do here is we say node.next, the specific node where this node which will be pointing to uh, node.next is equals to node uh, 4 is going to be pointing to 3, and node.next is going to be pointing to null. While we have a base case saying uh, if node is not equal to null and node.next is not equals to null. So this would be the base case, and here if you see, this would even make 3.2 null, right? So this way all the elements are reversed with stack. It requires a little bit of thought process or an imagination. That's something that I was even not able to explain. But yeah, take your time understanding the recursive approach because it is important for us, and it is the cleanest way in coding interviews to show your proficiency in recursion, right? Okay, so in the last session we had discussed on finding loop detection in singly linked list with um, hash maps, and Floyd's loop detection method where slow pointer and a fast pointer, or it is also called as hare tortoise method, where one pointer moves one step and the fast pointer moves two steps. And if there is intersection, then we say there is a loop that is detected in the linked list, right? We did it for singly linked list. Okay, so these are all the learnings that we had in the in the linked list topic. Hope you understood many of the concepts that we learned over the past 6 days or 5 days of learning. Please do post your thoughts or doubts or any sorts of interactions that you want with me in the comment section, or you can directly reach me out. Hope you found this video helpful. Please do like and subscribe to my channel. Until then, thank you.